Welcome to another video on digital electronics. In this video, we'll be seeing what is carry look ahead generator. Why carry look ahead generator is important? Because as we have seen a binary adder in which after every addition, the carry goes forward and then the next addition takes place and then the carry goes forward and the next addition takes place. So this is a bit time consuming and hence we require all the sums to be present at the same point of time. And hence we create a carry look ahead generator. So what here happens is once I have the first carry with me, I can immediately calculate all the other carries and I will have all the sums together without any delay. So delay is a very important parameter which is taken into consideration while designing a carry look ahead generator. So let's see how do we design this. For example, I have taken here a full adder which is a combination of two half adders which we have seen already in the last lecture. We are naming some of the elements here. So the output of the first half adder is called as pi and the carry is called as a gi. This is the third input, that is a carry which we are adding to the full adder circuit. This is the sum si and the carry here is named as ci plus 1. So this is c suffix I plus 1, right? I will just rewrite this again. So this is c suffix I plus 1. So what is Ci? This is the next carry, Ci plus 1. Ci is a previous carry, this carry which got added to the full adder. I hope this is clear now and hence this is called as Ci plus 1, right? So this is the carry generated because of the previous addition and this carry is because of the previous addition. So every time the carry gets generated, right? So since we have multiple bits to be added in a full adder circuit, we have time delay happening, and to avoid the time delay we create this carry look ahead generator. So we will write here some equations now. These are very simple and very logical equations. Very first one, we will write down what is pi. Okay. Pi, as we can see from here, this is nothing but a XOR b. So I will name this as ai and bi, right? Why am I writing this as ai and bi? If you remember the full adder which we had done, the ripple carry adder, I had a number a which had 4 bits: a0, a1, a2, a3. Similarly, I had a number b which had 4 bits: b0, b1, b2, b3, right? So to generalize this suffix, I am writing is that this as ai and bi, and this is the carry ci. So pi is given as ai XOR bi. Similarly, gi is given as ai into bi. The output, which is sum si, can be written as this sum si is nothing but pi, which is this pi entering this XOR gate, and ci. So this is pi XOR ci. And what is your ci plus 1? The next carry that you're generating, ci plus 1 is nothing but I have what coming here? Gi. I have gi coming here plus what am I multiplying in this AND gate? In this AND gate, I am multiplying pi, this pi, I'm sorry. I have not made one more connection to this AND gate. It has got only one input. This pi comes here, right? So this AND gate has two inputs. One is the carry, this carry which comes here, and this pi which comes here. So this is pi into ci, pi into ci plus gi. So gi plus pi into ci. This is your ci plus 1. So ci plus 1 is written as gi plus pi into ci. So we have written this outputs here, the output of the first half adder and the output of this full adder, which is the sum and the carry. So this is the intermediate output and this is the final output. I hope these outputs are clear. Once these outputs are clear, now it is very simple to understand how carries are generated from the very first carry. So the very first carry, input carry CO, if you remember, this is the input carry. I will scroll back to show you the full adder. See, this is CO which we had done here. We had grounded here, right? So this is the very first carry, the input carry. Now we will write down all the next carries that are getting generated. Next carry C1. So what is C1? I can write this carry from this generalized equation of Ci plus 1. So since Ci plus 1 is nothing but C1, which I am noting down here, which means I is 0 here, right? So if I put I 0 here, then I will have C1. So I is 0 means it is G0. The I is 0 here and I is 0 here also. So G0 plus P0 into C0. Exactly same equation. I am putting I equal to 0, which is the first case, to get C1. So I will write down here also I is equal to 0 and I get my C1. Let's put I is equal to 1. I will get my C2. So what I'm doing here is I'm writing this new carry in terms of the old carry. So once I have this old carry, the first carry, then it is easy to calculate all the other carries and then it will get added to the sum. And we do not have to wait for those carries to propagate, the intermediate carries to propagate forward, right? So I will write down now I equal to 1 and from which I can calculate. If I put I1 here, it is C2. C2 is nothing but G, sorry, G1 plus P1 C1. But see, C2 is represented as the previous carry C1. I do not want it as a previous carry because until and unless C1 comes, I will not have C2. So I will replace, as soon as I have my C0, I will immediately calculate my C2 also. So I will replace this C1 by this C1 here. So this is G1 plus P1. And what is C1? C1 is G0 plus P0. This is the only thing that you have to do for all the carries, right? So let's open this bracket. G1 plus P1 G0 plus P1 P0 C0. So see here, now C2 is in terms of C0 and no more in terms of C1. So I need not wait for C1 to come. As soon as I have my first C0, I can easily calculate my C2. Sorry for the lag there. Okay, let's put I is equal to 2. What happens if I put I is equal to 2 in this equation? I will have I equal to 2 means, which means I'll have C3. C3 is equal to G2 plus P2 C2. I equals to 2 here, right? So this is C3, G2, P2 C2. G2 plus P2. I do not want to wait for C2 to get my C3. So I will write my C2 in terms of this C2, which is in terms of C0, right? So C2 will be written as G1 plus P1 G0 plus P1 P0 C0. Entire this equation of C2 you should substitute. That's it. G2 plus P2 G1 plus P1 P2 G0 plus P0 P1 P2 C0. See here, now this equation do not have any C2. Carry 3 will not be dependent on C2 anymore, but dependent only on C0. That's the only thing that we have to take care. So this is your C3. I will finally write down the last carry. We are taking 4-bit as our normal addition. So I will take C4 as my last carry. Let's substitute I is equal to 3 and get your C4. I equals to 3. For I is equal to 3, I will go back to this equation. You can put I equal to 3, G3, P3, C3. So this will give you G3 plus P3, C3, G3 plus P3. This was my C3. So let's put C3 here. G2 plus P2 G1 plus P1. Sorry for the delay. It is having some delay. I don't know why. P2 G0 plus P0 P1 P2 C0 C0. G3 plus P3 G2 plus P3 P2 G1 plus P3 P1 P2 G0 plus P0 P1 P2 P3 C0. So see here, C4 is also dependent directly on C0, but nowhere you can see C3 term coming, right? So this is how you design the carries in terms of the very first carry that we are having. So after this, what we are supposed to do is we are supposed to make the circuit of this. So since you have all the equations with you, you know to do this is an SOP equation, right? So to get a product, you need to have an AND gate, and to get the sum between the products, you need to have an OR gate. So it is a two-level implementation in which first you will have an AND gate and then an OR gate. So I'm doing only for let's say for C1 and C2. I think C3 and C4 you can do it on your own. Otherwise, it will become very lengthy, right? So we have to discuss the last circuit also. So I will have your multiple wires. I will have G0, P0, C0, G1, P1, C1, G2, P2, C2. I think this much is sufficient to get the first circuit. So what is your C1? C1 is G0, P0, C0. So it is P0, C0, P0, C0 into an AND gate, and this gets added to your G0. Right? So this is your first C1. This is your C1. Similarly, you can make your C2. C2 is G1 plus P1 G0, P1 G0 AND gate. Then you have P1 P0 C0. So this is your P1 P0 and C0. This goes into an AND gate. And finally, for C2, you have G1 also added. So we have made this, we have made this. G1, I will add it to it. This is my G1. So this G1, this, and this. All three will get added into an OR gate and you will get a carry 2 here. Similarly, you can do it for carry 3 and carry 4, right? So this is your circuit how you will make. Now what is required is once you have generated all the carries. So as soon as you have your first carry, you can easily have your sums result. The last is the carry look ahead circuit. So this was the internal generation for the carry. But in a full adder, we have multiple half adders, right? So we need to make that entire circuit now. So this is how you make that entire circuit. So this is your carry look ahead adder or generator. Carry look ahead generator. The inputs that it will have is P3, G3, P2, G2, P1, G1, and P0, G0. Because we are adding four different bits, right? So if you add four bits, you will have four bits of sum and one carry. This inputs P3, G3, P2, G2, P1, G1, and P0, G0. What are these inputs? These inputs are generated from half adders, right? So all you need to do is make a half adder circuit here. This circuit that you made, this entire circuit that you made, this circuit is inside this box. तो इसमें जो P3 आया वो कहाँ से आया? This P3 is generated from somewhere, right? From where? The half adder that I showed you above. So this will have half adders. So this is XOR का output. P3 is nothing but your XOR output, and G3 is nothing but the AND of these two gates ka output, right? See here, I will scroll back again. This is generalized PIGI. But if I write this as P3G3, then this input has generated this P and G through a half adder. So you will have a half adder here, right? So this is, say, P3J3 is generated by A3 and B3. So this is the MSB, the most significant bit, right? So this is A0, A1, A2, A3, B3, B2, B1, B0. So we just added these two here, half adder, right? So you'll have multiple half adders. How many half adders? The number of bits you're supposed to add. Half adder for this, half adder for this. Four half adders, right? I'm extremely sorry for the delay that is happening in between. There is some glitch, I don't know what. Okay. So this P2G2 will again be coming through an half adder only. So you just have to make half adders. That's it. So this is an AND. This goes here. This goes here. This is your A2, B2. Similarly, two more half adders. P1, A1, B1. AND gate will generate G1. A0, B0. XOR. AND will generate G0. And you have something that is previous carry, C0, right? So this C0 is an external carry, your first carry that we are generating at the input side, right? So this entire circuit which you made, carry look ahead, is inside this box. And what is the output C of this? These are the inputs to the circuit. This is the output to the circuit, right? So the output is nothing but your carries C4, C3, C2, C1, and C0. So what is C4? C4 is as it is. This is your C4. This is the final carry of the sum, the final carry of addition of the all the bits. So what is C3 now? C3 is an intermediate carry, right? Which will help generate C4. But C3, we wrote it in some other terms. So in what terms did we write C3? C3, if you remember from these equations, C3, if you remember from these equations, C3 was written as I equal to 2. If I put, then I'll get C3, right? C3 I equal to 2. C3 is equal to G2 plus P2 into C2. So I will make here an XOR gate. This is your sum 3. Sorry for the delay. I don't know why it is happening. See here, this carry which we are getting, we want final sum, right? So the previous carry goes here. The previous carry goes here to get the next sum. And what is the other term that goes? Pi. So Pi XOR Ci will give you the sum. So now carry I have generated. C4 I am getting directly. I want all the sums, right? So to get the sum, how will you get your sum here? Sum is nothing but your carry plus your previous sum, which is Pi. So you have your carry, which is C3, and your previous sum, which is P3. So I will add a P3 term here. So take a P3 wire from here, jumper, and add it here. So this will give you your sum 3. Similarly, C2. C2 mein what will add to get your sum? S2 will add P2. So here is your P2. Again, there is a delay. I don't know why. Okay. Just make these jumpers. So this is P2, which will give you your S2. Similarly, C1, you will have to add P1. So say I will take my P1 from here. It is a bit easier. This is your P1. This will give you your S1. And finally S0, you will get from C0 and P0. So this is your P0. Take a wire from here. It doesn't matter if you take from upside or downside. You just have to make connections proper, right? So this is your carry look ahead adder with sums and the final carry C4. So this is the final carry of the output. I'll show you the full adder again. See, this is C4. C4, you do not do anything. It is just the output. But internal C's, you have to manage in such a way that you get the sum simultaneously. Why are we doing this? Why are we doing this circuit? We are doing this so that we get all the sums simultaneously. We need not wait for individual carries to propagate and get the next carry. So this is about carry look ahead adder. I think this is a bit longer video. I hope it was helpful. Thank you for watching. I'll stop here.